Good morning, guys. It's good to see you there prepared. Let's continue with our study. We were talking before about the earth. We were talking about water, and also now we're going to talk about something like air or the mixture of gases. Also, that's why we're going to describe the atmosphere as a tool. A tool for what? A tool for climate, and also as a consequence, the water in different parts of the earth. So if you pay attention to the presentation, as you can see, this picture is showing you some of the atmosphere is being seen. If you got a chance to watch this movie Ad Astra, for example, you can see it in the upper part how you can see the atmosphere. Also, it is a mixture of gases, which you already know, right? So it is important to mention that this mixture of gases, they have different masses, and as a consequence, different percentages are distributed around the earth. And as a consequence, they're going to give you this containing of, for example, nitrogen and also oxygen in different portions, but all of them mixed, as we call them, air, carbon dioxide, trace amounts of other rare gases, and also water vapor, definitely. So this mixture of gases known as air, so are going to protect the life, because as I said, the gravity traps the gases, and this atmosphere protects the earth by absorbing the ultraviolet radiation and reducing also the temperature extremes between day and night. That's why during the night it's pretty cold because of the change of temperature and stuff like that. So the atmosphere consists of also these layers. I'm going to show you there. I'm going to explain each one. So the outermost, which is called the troposphere, things slowly, so it fades into space with no boundary, but the air of the atmosphere moves in response to heating from the sun. So definitely there's going to happen something. That's why when you're watching a movie, you're going to see it when a rocket wants to enter the earth, the first moment it touches that part is pretty hot. It's because of that, because they colliding from this ultraviolet radiation from the sun is happening there. So if we continue with this, allow me to explain a little bit in detail there. So let's go to the upper part. Right, so the outer part, yeah, exactly, there it is. So the aurora caused by collisions, as you can see in this graphic, what I want to see is see the distance for the thermosphere there, right? If you pay attention to it, it's not that difficult to catch. It's just that this layer extends like 1,000 kilometers. You see, it's not that big, but the temperature increases rapidly after about 88 kilometers, and also there's a because in the outer part, the collisions are happening a lot. That's why it says aurora there. And let's move a little bit there. Right, if you pay attention to this, I already mentioned the temperature, which is really a lot and high and stuff. Right, good. Now, what if I ask you to observe this other portion, right? This one, exactly, that one. So, and then if you continue entering the earth from the outside, you're going to see there's the mesosphere. And the mesosphere, the temperature is constantly the lower mesosphere, but decreases steadily with about 56 kilometers and stuff. The stratosphere, temperature is a little bit stable. That increases due to the absorption of ultraviolet in that thin layer, the stratosphere. And then the troposphere, which is where the air mixes vertically and horizontally, right? So that's why we know the different cycles, the nitrogen, the carbon dioxide, the carbon cycle and stuff like that, also the water cycle. So all the water occurs in this amazing layer, the troposphere. Hope you were taking some notes about that. Well, so if you got this, yes, let's continue with the other part. If you pay attention to this, as a consequence, this is the tricellular module, the one you're observing in this moment. If you take notes about that one, it's really important in terms for describing, right? Because as I explained to you before in previous classes, the sun is touching the equator, which is the line in a vertical way, but in the other ways, it's colliding with specific angles. What is the meaning for that? If you want to describe that part, you're going to see that there's this atmospheric circulation of air, right? It's going to be heated in different temperatures, and as a consequence, the air is going to move and causing the climate to change. That's why I said a tool for climate. So the rotation and differential heating of the earth is a major effect on the circulation of the planet's atmosphere. As you can see, the tricellular module there is giving you some specific data. So the high temperatures over the equator and low temperatures over the poles, combined with the rotation of the earth, is going to produce a series of separated atmospheric cells that circulate at specific areas in the atmosphere. That's why it's called a tricellular module. So this module of atmospheric circulation, which I call it tricellular module because it has 3 cells, is because, as you can see in the graphic I am showing you in this moment, so the air is going to rotate in this way, into this way, into this way. That's why the Hadley say, ferrule cell, polar cell. Those are specific names because, as you can see, since the rotation is happening in this portion, then the air is rotating there with that specific temperature. The same thing here with that specific temperature, same thing with a specific temperature, and so on. The same thing in the South Pole. What's the meaning for that? That causes the climate to change, right? That's why we have, for example, we live in an amazing hot zone of the planet as the Ecuadorians. We have the tropical forest there. It's tropical in here, right? So because it is hot and it rains a lot, and the water evaporates, comes back because of the temperature in here, which doesn't happen, for example, the ones who got the chance to live in the north part of the United States, and so on, so on, so on, right? So if you take notes about this, for example, at the poles, the air cools, and the sands, it's a cold, dry, high pressure because of the temperature there. In here, right, in the center of the air, the warm air rises at lower altitudes and moves poleward. So because of the rotation, right, and also because the change of temperature into the air causing that. That's why maybe if you research a little bit, you can perhaps describe something that's happening. Why is that some hurricanes are happening maybe in the States, in Florida, for example, or stuff. If you pay attention to this, like the ferrule cells and the Hadley cells, for example, what is the ferrule cell? The rising mid altitude, right? It's following the poles in the equator, forming the ferrule cells. These mid altitudes in this spot, like in the above part of the center. Remember when I showed you the orange example, or the orange module touching the light in the center, and then to the upper part, the light is going to be different. In the tropics, the wind blowing towards the equator is part of the Hadley cells, which is just, do not worry about those. Those are just the specific names, which were named after the guys who were researching those. So Hadley cells is deflected by the Coriolis effect and forms the northeasterly and southeasterly trade winds because, as I said, as you can see in this module, the temperature, right, all the air is rotating, and all, which means it's changing, and the change of temperature sends a cold air to the upper part. That's why it goes to the upper part, and as a consequence, with less air and stuff, is going to happen in that way. The same thing for the north happens into the south, and as a consequence, the rest. So what is that going to cause in terms for, as you can see in this graphic, so that the average energy flow, for example, is going to happen depending on the place we're studying for. There's going to be energy transfer, there's going to be heat gain, and there's going to be heat lost. And that causes the variation of the climate. Remember the difference between climate and weather. Climate lasts a lot, right? More than 30 years and stuff like that. And weather is just the seasonal changes and stuff, right? So the energy gain from solar radiation becomes progressively less from the equator to the poles, and the heat gained at the tropics is transferred to cooler regions by atmospheric circulation, if you understand it. But so that's what I want you to see in this graphic. So in the tricellular module, and as a consequence, this graphic that you're seeing in this moment, so producing a more even spread of temperature over the globe than would otherwise occur if there was no atmosphere. So that's the amazing importance for atmosphere. The similarly heat gained by the oceans also transfers heat about the globe. So the ice caps of the poles reflect so much of the sunlight, they receive that they produce, and as the albedo we studied before. So if there was no heat flow, my dear, so the poles would be about 25 Celsius degrees cooler, and the equator about 14, and so on, so on, so on. So if you pay attention to that, this climate is affected by the circulation of the atmosphere, definitely. So it's a tool for the atmosphere is a tool for the climate. So the air rising at the equator produces a warm, wet climate in here where we live. So as the air travels away from the equator, it cools and descends as dry air. So the division of atmospheric circulation into the 3 separate cells I showed before in each hemisphere produces the climatic conditions that are mirrored on each side of the equator. So that's why we call them cells, right? Center, and then to the upper part, to the upper part, to the upper part, spreading the temperature. So these conditions are called biomes. As you can see, the biomes there are biomas in Spanish, which are large areas with the same climatic conditions and vegetation characteristics as you can see there. So that's what I'm trying to explain with this graphic: the cool, dry, the warm air, the dry air, and so on, so on, so on. And this nice graphic you're seeing there. For example, the cool dry air descending at the poles produces polar deserts. So because water remains locked as ice and so on, so on, so on. The warm air in the center, which is the tropics, so warm air rising at the equator carries moisture with it, which falls as rain, often violent rainstorms, and so that's why it rains a lot in here. So the warm wet climate produces the more biodiverse regions on the earth, as we know. But the dry air descending beyond the tropics strips more from the land as it travels back the equator. So I'll tell you how this doesn't decide some stuff of that. Okay, my dear, so what's the meaning for this? What I wanted to do, this graphic is going to be part of the explanation I wanted to do for this class. I wanted to say, first of all, I wanted to design a mental factor for describing the atmosphere, right? That's the first part. And the other part, I wanted to, based on the previous pre-works we have been doing before, and what we did during this class, I wanted to explain how aurora is caused. These two questions are supposed to be done into your